And then the end will be your opportunity to ask any questions that you have as you've hopefully been starting your projects. And then on Monday, attendance at the beginning at least is mandatory. The rest of the class will be for you to, again, ask us questions or to start working on your projects. You see this a little bit as bonus time if you choose to work on your projects. It doesn't count towards the 4 hours a week, but if you're having trouble getting data or you're still learning some good tricks for QGIS, then that's really what this time is for. Of course, it's really most important that if you have any questions that you come and ask the instructors. So let's see, first announcement is homework is coming back soon. Did you have any comments you wanted to share, Rich?
Well, only that everyone did a really good job, and all the maps are a little bit different from each other, but everyone obviously put some time into trying to figure it out, and it was a challenging spot. So I'm pretty much done with the grading, and I will be emailing them back to you today.
Great. Second note is that some of you know Arizona does not observe daylight savings time, which means that in November we cannot all meet at the same 9 a.m. So we have a few options, which is that we either move the class an hour earlier, an hour later, or somewhere in the middle. So to take a poll, particularly of the UNR students, would you be okay with moving the class to be on your clock 8 to 9:15? And if your answer is no, that's okay, but we do just need to know for planning purposes. You can either say your opinion or you can feel free to type it in the chat.
Yeah, so it'd be basically November 1st till the end of the semester. It'd be an hour earlier in Reno, if that could work. So, works for Sean. CJ, Jenna?
I could go either way. That works.
Okay.
Yeah, I mean 8 a.m. hurts a little bit, but I can do it if everyone else can. So
I hear you.
I agree. It is early. I think the problem is there's a few ASU students with class that starts a little bit after ours. So it would be
yeah, I have a class that starts at 10:30 after this class. So about 15 minutes after this one ends.
So it's hard to move back that direction.
Yeah,
it's hard. I agree, but at least you can show up in your pajamas, so no one will judge you on that if you're not already.
good advice, Ramon. Can eat breakfast too.
Yeah, it's like Zoom on top, PJs on the bottom.
Nice.
It's a 2020 mullet.
Okay, so let's tentatively plan on moving to 8 o'clock for the Pacific time zone. And if something comes up and you really just can't make that, then let us know as soon as you can.
But most of October is going to be the same schedule we're on right now, right?
Yes, so all of October will be the same, and then daylight savings time changes November 1st. And so you've still got a month where you can sleep in and not wear your PJs. Okay.
Well, we appreciate that.
Yes, we do. So we were also discussing the final week of the class. So at ASU, classes have to finish by December 4th, which is earlier than UNR would finish. And so our plan right now is to have everyone give about a 12-minute presentation either the 1st or 3rd of December. Instructions and guidelines on how to make this presentation will let you know well in advance. It'll be on short discussion of both of your mapping projects. And so UNR would then finish the semester a week or so earlier than you would otherwise. So you don't have to get up at 8 a.m. for the entire rest of the semester.
That's right. So essentially your final projects will be done in Reno, and school will still be in session, but we'll be done with this class essentially a bit earlier. So you have time to study for your other classes.
Does that sound okay with everyone?
So
what days were those?
ASU is going to be the same time.
It'll be the same, yes. If there's a conflict, let us know and we can figure something out. But ideally, it'll be the same time. And I imagine for UNR, that should be okay. At least in your ASU student with a conflict, let us know.
Wait, well, what I mean is it's still going to be at 9 a.m. for ASU, right?
Correct.
Okay.
Yeah. So at ASU, for the rest of the semester, there's no time change in the class.
Sounds great.
What was the last day of class you said?
December 3rd.
Thank you.
Okay. Any comments? So we'll now talk a little bit about georeferencing. So one of the good pieces of advice that Jess and Belle shared with us last class was to make sure that you do not look at any of the post-earthquake imagery. And so we want to make it very easy for you to not do that. So Ramon and I, mostly Ramon, are going to help you to do georeferencing for any imagery that you get from Google Earth. So when you talk about in a second, a few more details on how to get to this imagery, but when you find imagery that you like from Google Earth, then you want to save it, and in the folders that I sent to everyone, and everyone also has access to, you want to make a ungeoreferenced folder and add the imagery that you take directly from Google Earth to that ungeoreferenced folder, and then email me and Ramon that you've added it there and you would like it georeferenced. And then one of us will georeference it for you and let you know that it has been georeferenced. If you don't email us, we're not going to check those folders, and so we will not know that it's there.
Yeah, I thought of this as kind of like a georeferencing service. So you kind of submit the job to be done and it gets done and then we return it. And so just think of it that way. It's good for you guys to know how to do this georeferencing, but I felt kind of strongly that it's too risky as far as just biasing you, because some of these things are pretty obvious in the post-event imagery. So just trying to protect your sort of the purity of your minds, as it were. So then we can also have some feedback if it looks like there's a problem with the imagery. It also helps us with a little bit of quality control. Like one issue can be that if you're not at the right you can occasionally end up saving from Google Earth that is too coarse of a resolution and you can't really see what you're looking for. So we can provide
We're going to talk
feedback.
about that in 1 second, Ramon, in a little bit more detail.
So anyway, so don't be shy to ask for it. Let's get it going, but also be kind of realistic. Like let's prioritize like what's the most important images that you want to start with, and then we'll sort of iteratively, so you can submit like more than one georeferencing job. And in general, we should be able to turn them around within 24 hours. I think if it's not if it's just a couple images, it should be easy.
Yeah, at least at the beginning. Right now, there might be a few. If everyone's sending us images, it might be a little bit slower. And so we'll probably prioritize people that only have ungeoreferenced images to work from so that you can start. And we might do 1 or 2 images per person, even if you have more, and then we'll plan on coming back to the rest of your images later.
Yeah.
Okay. So let's see, share screen. So there was some, CJ asked a good question yesterday on how you can get the highest resolution imagery from Google Earth. So Google Earth is quite smart, and if you are at this level here, where you can see a lot of the Western US, Google Earth actually hasn't loaded the full resolution image at everywhere that you see, because it'd just be an enormous amount of data in your computer, and it would make your computer very, very slow. And so if you go to File, Save Image at any stage, then it will, you select maximum, it'll save the maximum quality of the image that you currently have loaded in your computer. And so if you were to do it at this level and you were to then zoom into Parkfield, you would not get the highest resolution image that you could get at Parkfield. And so we want to go look, we'll go look at Parkfield, then go here. I had the older imagery that I think was similar to what CJ was looking for. And see, again, if we zoom in or out, this older black and white imagery appears and disappears. And then actually when we continue to zoom into it, Google Earth at some point will load in the higher resolution imagery. So we see here may in fact be higher resolution than what we're seeing here at this zoomed out level, even though to us it looks essentially the same. And so when you save an image, you want to check that when you then zoom into the image that you saved, it looks like it's the same resolution as what you would see when you zoom in. And if it's not, if your saved image is lower resolution, then you want to zoom in a little bit further and resave the imagery. And so CJ's question also was, well, will you georeference more than one image for me? And the answer is yes, we will, and we certainly expect to georeference more than one image per person. But we do appreciate the sensitivity. And so you want to try to find basically an intermediate level of zoom where you can get the full resolution of the imagery, but then also that we're not just looking at a single field at a time, where it would take me and Ramon a very long amount of time to get you the georeferenced imagery that you ultimately need to use for your project. Does that make sense? Yeah. Are there any questions? Sean's giving me a thumbs up.
Basically, you're playing around with different years and different data sets and looking for imagery that is going to be helpful, and play around with different zooms and see, what you think you're going to be most happy mapping on.
And so definitely for the older imagery, you'll find probably that most of it is relatively low resolution, but you'll hopefully find a few data sets that are substantially better than the others, and even if they're not at the same level of resolution of the most modern images.
And sometimes you just get imagery that only captures a part of your field area. There might have been some, air photo mission flown at some point, and it might be an Earth Explorer, but it may only be a piece, but it could be, a pretty high resolution photo. And so you might consider using some smaller data sets and interspersing them with some of the bigger Google Earth data sets.
Hey, Chelsea, this is Alex Sarmiento.
Alex?
I had a quick, hey, are you guys keeping track of the scale of these images that you're referencing that folks are mapping on? Because I think that as I'm sure Chris and Steve have mentioned, that's kind of an item of interest.
So yeah, we've asked the students in their reports to include ultimately the georeferenced resolution of the imagery that they're using, as well as the source of the data.
Nice. Does everyone understand why that is important?
Maybe you could tell us.
Sure, yeah. So one of the kind of exercises that everyone's interested in on the industry side is if we have a site that we're evaluating for fault rupture hazard, and we can map a fault beforehand, that can be scale dependent, right? So if you know the actual mapping scale, then you can calculate the error in the map location of the fault, and numerically you can account for that when you're trying to assess where the fault might rupture the surface. So if you keep track of the scale, then you can numerically account for the location error. That's kind of the short answer.
Mm-hmm.
All right, thanks.
Great. We actually have two people who will be working in Parkfield from data acquired about 40 years apart. And so for that case, it'll be very interesting to see how the data from several decades with different technology will impact what can be mapped.
Very cool.
Any questions from the students in particular? Everyone understands?
I have a quick question.
Yes.
So on the shared document, I'm on doing the EMC. There was LiDAR data from OpenTopography. I have that link, and I also see Google Earth. Should we be using both data sets to map, or just one or the other?
So you'll probably want to use both.
Okay.
And as Belle and Jesse showed, they were able to make different observations in the different data sets. And remember, we also asked that you, in your shapefile, you write which data set you made the different observations of the faulting from. Again, because we expect that different features will be seen with different clarity in both of those data sets.
Cool. And then I also saw that the shape files for that one had 2 polygons.
Yes.
Kind of next to each other. Should I do both or one of those?
Do both.
Do both. Okay. Cool.
Yeah, so there are a few, particularly for the larger earthquakes, where we don't want you mapping the whole length of the fault from the pre-rupture imagery. because we think that will just take more than the 20 hours that we're giving you. And so I've sub-selected a few areas that I think are interesting and show different features for you to focus on.
Cool, thank you.
Okay. So our next topic is to talk about OpenTopography. So if you'd like, you can follow along and repeat what I'm doing, or you can also just watch if that's easier for you, and then repeat this later if you need to do so for your assignment. Just trying to get the chat.
Now, do we have to create an account for OpenTopography to download any of this?
So if you, it's a good question. If you, just sending the link. So today, for the demo, you'll be able to follow along and process a small data set without making an account. But if you're using OpenTopography data for your main project, then you will want to make an account because it will let you process a larger data set at once. So to make an account, you go to my OpenTopo, and I'm already logged in, so I won't be given the option to make an account. But if you come here, it will not look like this screen, but instead you'll have a login option, and it'll say if you don't have an account, click here to make one. So today we are going to, so in the chat you should see this link for opentopography.org. So if you want to follow along, please click there. And then today we are going to work on processing a data set. This one is going to be in Pennsylvania. So you want to click data, and that will then take you to this map of the US, where you will see all the data sets that OpenTopography hosts in the US and adjacent countries. So then we'll zoom in to Pennsylvania. You zoom into the center of the state. So here's Pennsylvania. Here's State College, Penn State is. So we're going to look at this data set here. Then you come here, it says select a region. You can put a little box over a relatively small portion of this data set. And then you come down here, and I will show you the two data sets. So Susquehanna Shale Hills Critical Zone Observatory. We have two options. Let's look at the leaf on version. Zoom is being annoying. So then first we'll go to point cloud. So you get a page for the data set. So there's some interesting metadata. In particular here, you'll want to look at point density. So that we see that we have 14 points per meter squared. So that means in this data set, we have about 13 measurements of elevation per meter. So it's quite a high resolution topography data set. You can also see that it was collected in summer of 2010. So here is our area. Again, this has Valley Ridge topography. It's definitely not the desert, has lots of forests and agriculture. So we can come down here and then set number of parameters for the processing. And one thing that you'll want to pay attention to for this class is this area where it says choose return classification. So you have options in many data sets of ground, unclassified, or to exclude noise. And so whatever you click is what points you will ultimately download. So if you're working in a desert, most of your points will be ground and, for example, not unclassified. Classified typically includes different types of vegetation. But in Pennsylvania, where it's definitely not the desert, most of the points are actually going to be from this unclassified group. In other words, from vegetation. So you see here we have 210 million points from ground and unclassified. But if we unclick the unclassified, so we're just looking at ground, then we have only 14 million. So we lost over 90% of our data because most of the returns to most of the measurements of the elevation are from trees or other points that are not the ground. So if you're working, say, in Japan, or as we learned in Seattle, if you ultimately look at the full data set, the ground and unclassified, you're just going to see the trees. So keep in mind, particularly if you're working in the non-desert climate, that you want to just look at the ground points. Are there any questions?
I would assume like for EMC, it doesn't have those options. I guess it's just you're given what you're given.
So some of the older data sets which EMC is, you're just given what you're given. EMC is in a climate quite similar to Phoenix, if not even drier. And so there, it's also, you're not, even if you had some trees in your data set, they wouldn't really be that much of a problem.
So Chelsea, I've got a question. When would we ever use that exclude noise? What is that?
So there's a few points that are noise that haven't been well classified. So here, there's actually no points that come in as noise. So generally, you can not include the noise. Very few data sets actually have this option. That would be, for example, from birds flying or just things that really aren't representative of any feature on the ground.
Gotcha. Thanks.
And then another parameter that you'll want to look at is grid resolution. So if we were, say, in the desert and we had 14 points per square meter, then we could make the digital elevation model at a pretty high resolution, say 0.5 meter, because we have many points per meter, many elevation points per meter. But in the case we're in Pennsylvania, where most of the measurements are of trees, but now we're only interested in the ground, we can leave this parameter as 1 meter, which is the default. But again, if you're more in the desert and you have a newer data set, you may want to experiment with, instead of gridding at default of 1 meter, grid at, say, 0.5 meter and see what your data set looks like. The EMC, in contrast, is an older data set, and so I believe the default resolution is 6 meters. And you can grid at a finer resolution, say 1 meter, but you won't really be gaining any extra resolution to your digital elevation model. So if you want, you can make a hillshade. And like we learned in QGIS, you have these options of altitude and azimuth of light. So you certainly can make different hillshades on OpenTopography, and they'll be ready to download and use. You can also, and I often prefer to take a digital elevation model from OpenTopography and then use QGIS's tools to make the different hillshades or the slope shade. Yes, Ramon had some good comments on how to figure out the best way to grid your elevation data, the best resolution. So then you can come down and you'll have some options. So you can write a job title. We could say Susquehanna ground. You can add a description if you want, and then you'll have to add your email here. And if you've made an account and logged in, then your email will appear automatically. You can press submit, and now the job that we just executed is being processed at San Diego Supercomputer Center. And I actually ran this last night, so we can look at the results. So we get Susquehanna ground points. It took almost a minute to process. And see here you have DEM results, including this. So this zipped folder, you'll find the DEM that we just made. So if you're working on a Mac, it's very easy to open this file. If you're working on a Windows computer, it's a little bit more difficult, but you'll want to use a program like 7Z to open up this GZ file. Here's the topographic hillshade. And then for reference, process the exact same area, but included the ground points and the unclassified points. And so as we expect, we see that there is substantially more vegetation in the area, and our ability to see the ground surface is not nearly as good. Are there any questions?
I have a quick question. When it comes to the coordinates and classification, did you manually put in your coordinates?
So to pick the area, you put a box over it, and then the default is to process that box. So this is the same box that I had before. And then if you want, so these are the coordinates of that box, and you can click manually enter selection coordinates, and then you can change the coordinates here.
Perfect, thank you so much.
So if you have a large data set that you can't process all at once, in that case, what I would suggest is that you process in several groups. So you, say example, could process here first, and then the next time you could process here, and then in the third set, you could process this most eastern section of the data set. So a different way, some of the data sets that could work well for processing are to notice that you also have a raster option. In some sense, this is a faster way to download a digital elevation model for your data set. And again, an important thing to note here is where it says raster resolution. So it's going here, we can fairly quickly download a raster with a 1 meter resolution. So if you're interested in, say, just the ground points, 1 meter resolution is probably about as good as you can get. If you're interested in seeing the whole structure of the forest and the trees from the top, then you may want larger than 1 meter resolution. In other words, you wouldn't want to get just the 1 meter raster data set. But say you want to, you do decide that you want to download from this raster option. So you can select here, and then it tells you that you're interested in processing 124 kilometers squared of data. And then important here is to come down and decide if you want the digital terrain model. The digital terrain model is what you'll see, essentially the bare earth surface, so the trees will be removed, versus if you process the digital surface model, where you're looking at the surface of the landscape, and in this case, the trees will be included. So for most, if not all, of the projects that we are working on for the mapping, you would want to download the digital terrain model. And again, you have similar options with deciding how to make a topographic hillshade. Or you can repeat that similar calculation in QGIS. So again, you can press submit, and when you press submit, it starts the job running. You'll get an email when it finishes. And if you've made an account, then you can also come to user, that's all you'll see, and point cloud or raster jobs. So if you go to point cloud, then you'll see that we just ran this job called Susquehanna Ground, and it's already finished running. Ran a couple last night. So you can click there and view these results again. Does anyone have any questions?
One thing here, Chelsea, maybe you were going to show, but just if you click on that view with Google Map, you can kind of quickly use it as a way to check things that it's in the right place, and just toggle the show hide so that we get a sense, especially here, maybe if you zoom in a little bit more, you get a sense of the value of a digital terrain model in a vegetated environment, and also how the information that's provided from a hillshade is quite a bit different than the information that's provided from the visible near infrared image that we're looking at. Both have important value for your work, and so that's why you may end up using both, because they provide different kinds of information. So anyway, you always use that that thing as kind of a quick check, because it's accessible in the browser with these.
Yes, just be patient. It does sometimes take a few minutes to toggle the DM hillshade on and off. So as you saw there, I briefly couldn't get it back on, so then I re-executed the Google Earth window. Actually, and now will eventually come back, but again, it's slow, and so it can be faster to just come here and click again. So Ramon and I and Alana have lots of experience working with OpenTopography, and so if you have any questions, then the three of us are also good resources for you to ask on how to access different data sets. And so actually for many, if not all of the areas where you are working, the pre-earthquake data sets also have a post-earthquake data set pair with them. So be very careful that you are just getting the pre-earthquake data set.
Yeah, just for a small historical piece of pride for us in ASU is OpenTopography was invented basically in my office. Chris Crosby was one of my students at the time, and he kind of said, you know, this high resolution topography is a real problem for how do we share these data and get at it, and how can we build a tool that would let us access in a sort of efficient way. And 10 years later, or now slightly more, here we are.
Yeah, it's an awesome resource. This is Rich, and you know, I kind of claim myself as a brute force user of OpenTopography. I just grab what I need and I get the stuff downloaded. But Ramon and Chelsea and Alana have a lot more experience with the finer details of it, so I can answer questions as well. But I've been using it ever since it came out, and it's just an incredible resource.
Yeah, brute force is good. Try to break it. We'll be happy to see what, how we can improve it.
Yeah, I mean, I'm always learning and coming up with questions. So, but they host data from all over the world. It's pretty incredible. And I've lobbied a few data acquisitions to be submitted to OpenTopography, but some government agencies are a little reluctant to give up. They kind of want to host their own and stuff like that. But I always say it's just better at OpenTopography. So, save yourself some hassles and get it into OpenTopography, and they'll serve it up to the world. But yeah, it's an incredible data set.
Thanks.
So yeah, back to the point a few minutes ago. So if you're looking at the Almayer Kuboka earthquake, you'll see we have this 2016 data set from prior to the earthquake. And then actually all of these other data sets are after the earthquake. And so again, you want to be very careful that when you are downloading the data, you want to make sure that you get the pre-earthquake data. So if we look at this one, rupture LiDAR scan, it's already a pretty good hint that it's after the earthquake. Say we click on point cloud, then you can come here. We know the earthquake was in April 2010, and this tells you that the survey date was in August 2010. So you know this data set was collected after the earthquake, and it's not the one that you want to use.
So when I search Parkfield, all I get is, I only get one result, and it looks like it was done in 2018. So I just don't have anything for that project, I guess, here.
So yes, Parkfield, there is no pre-earthquake data. And so you have to use just either the Google Earth imagery or the USGS Earth Explorer imagery. But for your second project, you may have an example where you can use these different topography data sets.
And it's good to just be able to be versatile and use different data sets as well, because other places you're going to be working around the world, if you get a job doing this sort of stuff, you may not have LiDAR everywhere. So you got to be well versed at all the different styles of imagery.
Are there any questions about OpenTopography? How you can access data?
Your explanation was really well done. It seemed to work really well. Thanks.
Great.
Did you already explain what the difference between the red and green boxes are? I might have missed that.
It's a good question. So if you come up here, there's a legend where it says the red are OpenTopography. And so these are going to be data sets that OpenTopography hosts at San Diego supercomputer. And they are, many of them have been in OpenTopography for a while, very much part of the OpenTopography system. These green ones are USGS 3D elevation program data sets. And so these are collected by a large program funded by the USGS, largely by the USGS, to collect national LiDAR data. And they are currently hosted by OpenTopography. And you can access these data sets in a very similar way that you would to the red data sets. However, you actually, to use these green data sets, they're really in a trial period for people with academic emails or academic affiliations. And so to access any of these data sets, you need to have made an account with your ASU or UNR email addresses. If we zoom out, we notice that there's not really an equal distribution of green areas throughout the US. In particular, there's a lot more green in the Midwest, and to some extent in the East, rather than we have in Arizona or in Nevada. And this is because these data sets are partially funded by the federal government, but then they expect local stakeholders to raise about half the funds for data set collection. And that's easier to do when less of the land is owned or managed by the federal government. And so as many of you observed for the USGS Earth Explorer, there's many more data sets in the eastern half of the US or over urban areas in the West. And again, this is the same reason that we see this different distribution of data at different parts of the US.
Chelsea, I had a question. Maybe Ramon or yourself can answer this. When 3DEP has a data set, once it's gone through quality control and processing and everything, how quickly does it go to OpenTopography?
So they're loaded up in cycles. But at this point, now that we've figured out how to ingest them into OpenTopography, it's relatively quickly.
That's awesome.
Like a month or two at most time scale.
I asked for selfish reasons because there's a big 3DEP acquisition happening in the Walker Lane and Western Nevada, which I will be using. So it's being flown now or this fall sometime, I believe.
Yeah, so it's that time after it's on the or it's ready for access via the USGS. So it's still some time after the acquisition.
Yeah, cool, thanks.
Okay, so now we should talk for a few minutes about there we go. Primary versus secondary faulting. Computer is not letting me get to the window.